We're out here today working on our 8-row planter and looking at how 360 wave is performing compared to other closing systems here in this soil, where we're looking at how each row is helping close the trench behind this planter. So 360 wave is our starter attachment on row units that also comes along through our seed trench and helps peel the sidewall over on top of the seed we've just planted to help aid our closing system to finish off the job here in closing our trench. We're comparing today against 7 other systems. We have standard OEM rubber closing wheels. We're comparing against a 15-inch spike. We've got a tine style closing wheel working on this planter, as well as a rubber spike style. We then have our cast wheels, and we have 2 versions of a 2-stage closing system, one that's controlled and one that's not. So we're going to go ahead and work our way across these rows and look at what do we find underground. Here at the surface, it looks pretty good. We don't really see any voids. We've got reasonably dry conditions here at the surface, and so it looks pretty good. We might leave this field and feel really good about the job we did. But we know we need to dig a little deeper, we need to go underground, and we need to study how are these systems really performing where it counts, right next to the seed. Are we leaving any air pockets? Are we leaving any voids? Are we allowing dry dirt in with the seed? We know that emergence is critical when it comes to yield. And these are all factors that can contribute to lost emergence quality. We're going to see more late emergers that are going to result in smaller ear count and smaller ears throughout our field. So we know closing is an important thing, and we're looking at a variety here that's going to teach us what works and what doesn't work on our plant. So this leaf blower is becoming my new favorite tool to evaluate closing and being able to see what's happening underground. It looks good here at the surface, but we want to find that both sidewalls have come back together and we haven't left any voids and that there's moisture around the seed. Okay, to start with, let's look at row number 1, where we have a 2-stage controlled closing system. And we're going to use the air to blow open this row and take a look underground to understand what's really happening. How does it look at the surface, which actually looks pretty good, but the key is how does it look down near the seed where it really counts? So as we start to look underground, the real evidence starts to show up of how a closing system's performing. So here we start to see gaps near the seed. And you notice that the divots have been left from the disc up front in the closing system as they're trying to bring those sidewalls together, but it's not able to fully do it. So we're still seeing air gaps near the seed along the row here as we blow this open. So as we start to look closer, we start to see seed in those air pockets, and we know that anytime we have air around the seed, that's a risk for germination. That could cause us to have late emergers and yield loss. So we're looking for a closing system that's going to be able to bring those sidewalls together and be able to get full, complete closing from top to bottom. What we're seeing with the 2-stage closing system is even though it's controlled, it still has the disadvantage of working only from the top. So it's trying to push force down, it's trying to push force in from the sides, but it's not enough to really bring soil together and stitch it from top to bottom. So now let's dig in and look at our dual stage fixed spring closing system. So here on this dual stage system, we've got discs coming from the outside, and they're out here where you can see the marks have been left, trying to bring this closing system through here to bring the sidewalls back together. So as we work our way through, we're able to find the slot that's all the way down to seed depth. So you can see I bring the screwdriver in here, working its way all the way down the length here. So in this clay soil, it's a denser soil type. We're starting to see the evidence right through here that we'd like to bring this sidewall closer together, stitch that together better than what we're finding. So now let's take a look at our cast closing system. In the past, when we've looked at closing studies, the cast closing system's usually done a really good job. In many cases in plots I've been part of, it's actually won the plot. So let's take a look here and see what we find. So one of the things I like about the cast wheel is how it's shaped right at the tip. It's a V shape that's being used to direct the force to close our trench here towards the middle. And you can see here, if you look, that pattern shows up here in the soil. So once the loose dust has been blown away, what matters here has been exposed, and you can find that V pattern that I think is one of the advantages it has over some of the other closing wheel choices. It's going to earn a higher grade today. What we're seeing here is what we want to find. We're not finding our seam anymore. I don't see any evidence of where the sidewalls have been brought together. So I like how it looks right through this section. We do find a few spots here though that I still would be critical of. We're finding a void here, starting evidence of a void there as we've used some air on this seed trench. So some areas that we like, some areas not quite as good, but better than some of the others that we've seen. So here we're finding what you would want to see, which is as we get down to our seed depth, right through here, I'm not finding much evidence of any kind of sidewall that's been brought together. So it's got a nice consistent closing all the way through. So as we work our way through here, we'll kind of find our next seed. Here we start to see a little bit more that's a little easier to get the screwdriver. And in fact, as I work in this void, I do find a seed here. So one of the good areas, we like what we see. Here I'm finding one spot that's not quite as good, but again, better than some of the other systems. So here on this row, we're looking at our rubber spike system. On each side of the row, we have an identical wheel, what I call a rubber spike. And you can see the divots that have been left here at the surface working on each side of the seed trench. So there's some evidence here that it's a bit of a different pattern than what we've seen on some of the other closing systems on this planter. But let's go underground and see what it looks like below. So here in our rubber spike row, we're finding the evidence then left behind, and this is where the air really helps us see what's going on. You can see the divots here spaced out along each side of the row. And one of the challenges for a spike style is to be able to have the force to bring the sidewalls together, to really be able to push towards the middle. So we're running on spring setting 1 here, and these are pretty good conditions today. We've got nice dry conditions, it's not overly wet, so we'd like to see this system performing a bit better. So on this row, we're running a tine style closing wheel. It's got steel fingers working together on each side to come towards the middle, and it looks pretty good at the surface. Let's take a look underneath. Okay, so on this tine style closing system, we can see here right under the ground an imprint left from each tine. So the evidence is here of where this closing system ran. You can find the marks working its way all along here. This system's got quite a bit of surface area trying to work on the ground, so it can be held up. And you can see that effect here in the middle, where there's a lot of this trench that hasn't been brought back together. The system's struggling to be able to apply any kind of sideways force to be able to stitch this soil together like we'd want to see. So it may work in some conditions, but what we're finding here today, I'd give it a pretty low score compared to our other systems. I'm seeing a lot of the trench open here. I'm seeing a seed in that pocket, and working our way through as we continue to use some air here, I think we're going to see a lot of these seeds looking at us. So we're running here on this row a single spike wheel, 15-inch spike, next to a rubber, and the spike's up front and the rubber's being used to come along behind and tamp things back down. Typically we're trying to use a spike like that to chop open the sidewall. In the past in our operation, we'd run that kind of setup before we started to control our downforce. The goal, of course, being to try to ease sidewall compaction, let the root system develop at least out of one side, even if the other side is still a bit tight. So we're going to let's look underground and see what we find. So now we've opened up our single spike plus rubber row, and we can find, as usual, the evidence here of what's been done by our closing system. So on this side that's closest to me, we have the rubber wheel. You can see a little bit of evidence if you look close of where that tread is run, just the rubber itself. And then what we're finding is on this side, without any opposing force, very little coming from the spike, it's fairly easy to leave quite a void right through this section right through here. Some areas look a little bit better, but generally overall, I think this system is struggling a little bit in these conditions. We're finding evidence right here of where each spike has penetrated. Definitely want to look at our centering when we run a system like this, making sure that our closing system is lined up right over the row. This spike is real close to the seed. Even though we have it spaced over like you would be recommended, you're still finding as deep as that spike runs, almost down to seed depth, that it can get pretty cozy. So we want to make sure we're centered, but we're still finding that yes, we have disturbed some of this sidewall if that's the goal, but we're not doing as good a job on closing. So as we work our way across the planter, we're now looking at what we would consider our standard closing system. It's what we're all used to seeing on planters, 2 rubber closing wheels running side by side. So as we look at our 2 rubber closing wheels, you get the thought that sometimes simpler is better. We're finding some areas that look okay. So right here in front of me, this section stitched together pretty well. Here I do have a void, here I have a void, so it's not perfect. We still find areas that could be better. And it's what we're finding throughout this whole planter so far. Every closing system we've looked at is all trying to work from the surface. All it can do is use our spring force that's on our closing system or an airbag, whatever's being used, to apply force down on the top and trying to pinch this sidewall together. And it just is sometimes out of reach. So as our topography changes, the closing system moves coming across here, we're not able to consistently stitch it back together, even though in some areas it looks okay. So on this row, we're running 360 wave. It's running out ahead of our closing system. We're firming in the seed first, then we're bringing our knife alongside Cutting moist soil out of our right sidewall and folding that over the seed, we're then able to apply our starter, and then after that we just have a standard closing system. We're running 2 rubber closing wheels in spring position 1, followed by a drag chain. So let's go ahead and dig in here and see what we find. So now we've started to take the same view that we did before on our 360 wave row. We're looking at the same type of picture that we saw, but what's different now is this surface is looking a lot more consistent all the way through here. I like what I'm seeing, and what's happened here is we've given our closing system an easier job. The blade that's running up ahead has started to pre-close the trench, bringing moist soil over the top of the seed, making it harder to leave any voids through here. So there's some loose material to work with when our 2 rubber closing wheels come through to finish the job. And we start to see that here, where it's pretty consistent all the way through. So again, your bandit disc is here, your bandit disc is here. So right here through the middle is where we're gonna find our seed. As I work all the way across here, it's nice conditions all the way through, and I'm not finding any voids as I work all the way through here. So what we're gonna do next though is let's go ahead and find the evidence of where the blade ran. So soil has memory. And we find that when we use the air. We're able to dig down and you're gonna find the mark of actually where the blade was, and then let's start to uncover the seed. Okay, so you can see our blade mark right here along the right side of our seed trench. And what's good is there's not a lot of evidence of where the center line is. You really have to look close. You just see little glimpses now and then, like I get a little bit right here that starts to give me some evidence of where is the middle of our seed trench, where that left side has been left standing, and we brought moist soil from the right side over to finish out our closing. So as I work along that edge, you can go ahead and find the evidence like I see right here of our sidewall, and I can peel this wave now back towards where you're looking, and we should find seed as we work our way through. Look at all the moisture we've got in over the top of this seed, which is exciting for consistent emergence. We're gonna get that seed to take off at a consistent time. We firm the seed down, so we're gonna just have to work down to our seed depth, make sure. Right here I start to find him. Look how encapsulated on all sides that seed is as we work our way through. He's pushed in behind this wave. He's got fertility, starter being applied right here. He's gonna be happy as he takes off. He's living the good life. Work our way through here. Jump up a few inches. Here's our next seed working along the sidewall where we'd want to seam. Same way here. Fully encapsulated all the way through on all sides. So let's take a look at the details of how 360 wave works. We mount the wave system right here in the middle of the row unit behind our seed tube or our seed delivery device. And we're going to come through and first start by firming the seed to the bottom of the trench. So we're going to firm our seed here, and then the blade is going to come along and cut moist soil out of the sidewall and bring that soil over the top of the seed to help improve our closing and give that closing system that's coming along behind some loose material to work with. At that point then, our liquid tube is coming down the back of the blade, and we're able to apply our starter or biological or whatever liquid we want to apply near the seed, 3/4 of an inch to the side off the back of the blade. So whether you're running a Deere or a Kinsey planter, ExactEmerge, high speed, standard tube, we've designed Wave to mount in a lot of different planters and different combinations of attachments you already own. In the case of a standard Deere row unit, we're replacing this closing casting to give ourselves a new mounting face that hasn't been able to be used before in a row unit, that allows us to come in and stay clear of everything else that you're going to have in that row unit. In the case of running 360 Bandit that would be applying our nitrogen near the seed, we've got an additional bracket that would go underneath the Bandit itself, keeping this blade in the correct position. And there's 2 joints in the design that allow us to run a blade close to the seed and not cause any issues. The first one is the blade pivot joint itself that allows us to go around right-hand turns, and the blade is acting like a rudder. It's naturally steering itself so that as the planter moves forward, this blade seeks to the correct position and is able to move away from the seed if it was ever in a position where it wanted to get close. So that joint's very important for us. We know then that we've got our stop here positioned off the frame so that the blade itself can't go any closer to the seed than that 3/4 to an inch. We also have designed it then with a rock joint, so the blade itself is able to pivot up and out of the way, and it's held down by our spring here behind our spring shield,
so that as the planter's going through any kind of terrain that's got obstacles, rocks and these sorts of things, this blade can move up a full 2 inches to get up and over anything that might be coming through this row unit. So we've also thought about the flow of material. The frame is designed to make sure nothing plugs. The trash shield here up front picks up any material that's coming loose off of the row unit and slides it out underneath the blade to make sure everything keeps flowing the way that it should. So we call it 360 wave, and the angle on the blade is important to being able to cut the soil in the right way so that it folds over the top of the seed. We've protected the blade itself with laser cladding. It gives it a long wear life. We've protected all the key areas throughout the design with the laser cladding. The blade itself is slant sharp. It's angled in the bottom so that it continues to self-sharpen over time, and that way it's also naturally ruddering, so it always ends up in the correct position. So looking closer at the firmer that's here at the front, we know that it's important to firm seed to the bottom of that trench and get good seed to soil contact. We've designed our firmer to make sure that that whole process is finished before the blade is ever going to come through and start to bring more soil into the trench. We've also designed the mounting location to match some of the other firmers that are out there. So every wave's going to come with ours, but if you want to run some of the other choices, there's some smart firmers out there, for example, this mounting location is going to work for those as well. With 360 wave, we have choices on what type of liquid we would like to apply near the seed. Because we've designed it so that the liquid's actually applied off to the side, that 3/4 to an inch, and at or just below seed depth, we're able to run higher concentrations of salt. We're able to run starters that you would never want to run on the seed, and we're, in the case of wave, running as much as 15 gallon per acre. So we've got choice on what type of product we'd like to run. We're safe in keeping it away from the seed, and we can run higher rates than you might think you could otherwise because of the way 360 wave's been designed. So let's take a look at the yield results coming out of our plot. We've taken our 8-row planter, as you recall, back in the spring, and we've tested different combinations of firming systems and closing systems. And we're looking at now what really paid off and what made a difference. As we go through the plot, we're using just the firmer and the rubber closing wheels as our baseline. We're comparing every other combination to that. So what we saw for yield was 225.2. So now as we work our way through the plot and we compare it to that combination, you know there's a lot of closing wheels you can try out there. We've tested a number of them. In this case, firmer plus furrow cruiser was 1.9 bushel better than our baseline. As we keep working through, we see firmer plus cast at 6.2 bushel better. And that's pretty typical for what we'll see here in our area. We really like cast closing wheels. We think they do a great job, and it shows up pretty consistently in our yield data. Then as we work our way through to the next trial, firmer plus our 2-stage controlled closing system, 6.9 bushel better. Fairly similar to firmer and cast wheels. Then we have FurrowJet and the 2-stage closing system coming in at 11.6 bushel better. Then we get to where we see wave starting to show up in the plot. Wave and rubber. Combining those two, 14 bushel increase over firmer and rubber. So we know that wave is making the difference for us. 360 wave being designed to close that trench from the bottom up, bringing moist soil in from the sidewall is making the closing job easier for these rubber closing wheels, and it's showing up in yield. And then we see our best combination of the plot, 360 wave and cast closing wheels. The trend continues where the cast closing wheels are the best closing system, and that's the advantage of 360 wave. We're working ahead of your closing system. You still have the choice to run whatever works best in your particular soils. And for us, the cast wheels combined with wave, 14.5 bushel advantage, and the overall winner in our plot. So we're excited about the results we're seeing in this plot. Add to that what Sunnybrook Farms saw in north central Illinois. There they did a side-by-side comparison on their planter across 57 acres. And they were comparing 360 wave with rubber closing wheels to the dual stage closing system that's automated. And there they saw across that entire field a 4 bushel advantage to 360 wave. So again, where's that come from? It's because 360 wave has been designed to think about how do we take that seed and start it off for success. We know we need to firm it to the bottom of the trench, then we need to get moist soil next to that seed, and we're going to do that by cutting soil right out of that sidewall. We know we need to close the trench correctly. 360 wave starts that process, and we make the job easier for whatever closing wheels you're running on the back of your row unit. They're going to come through and finish off the job. And I think you're going to see the same results we're seeing in these plots in your operation.